All right, let's dive into a theory that is, well, as mind-bending as it is beautiful. It's called the prime wave resonance theory, and it suggests that there's a single hidden code connecting the biggest things we can imagine with the absolute smallest, all based on a pattern you probably first saw back in grade school.
So, it all kicks off with this really powerful question. What if the answers to everything, to the whole cosmic puzzle, weren't some brand new exotic particle we have yet to find, but were actually hiding in plain sight, in something we've known about for thousands of years, prime numbers? The big idea here is that these basic building blocks of math might just be the basic building blocks of reality itself.
But, before we can really appreciate just how big this idea is, we need to talk about the problems it's trying to solve. Because modern physics, for all its successes, has some, let's say, enormous, gaping holes in its understanding of the universe. We're talking about the biggest questions out there.
Okay, first up, the expansion of the universe. For a long time, we knew it was getting bigger, but then came the shocker. We discovered that the expansion is actually speeding up. It's accelerating. We gave the mysterious force behind this the name dark energy, but we have no idea what it is. And that's a huge problem, especially since it apparently makes up nearly 70% of, well, everything.
Now, let's zoom way down to the subatomic world, right into the heart of an atom. There's another puzzle here. Why is it that some combinations of protons and neutrons are super stable, lasting for billions of years, while others just fall apart in a split second? The forces involved are incredibly complex, and being able to predict this nuclear stability is still a massive challenge.
And then there's the universe's missing stuff. You see, when we look at galaxies, they're spinning so fast they should, by all rights, just fly apart. The gravity from all the stars and gas we can actually see isn't nearly enough to hold them together. So we figured there must be some kind of invisible dark matter, acting as the extra gravitational glue. But just like dark energy, we still don't really know what it is.
So, you've got these three massive mysteries on totally different scales: the cosmic, the atomic, and the galactic. The prime wave theory comes along and says, hey, what if there's a single key that unlocks all of them? And that key, believe it or not, is hiding in the pattern of prime numbers.
At first glance, primes look totally random. 2, 3, 5, 7, 11, 13. There's no obvious pattern. But then, mathematicians found something incredible called the Prime Number Theorem. It showed that while you can't predict the next prime number, you can predict their average spacing with shocking accuracy. It was proof of a deep, hidden rhythm buried inside the chaos.
And this is where the theory takes this brilliant leap. It takes that hidden rhythm and completely transforms it. So instead of thinking about primes as these separate individual stepping stones, it develops a single, smooth, continuous wave that passes perfectly through the location of every single prime. This is the prime wave. This is the secret code.
Okay, but how on earth can a wave based on numbers explain why the universe is accelerating? Well, the theory's answer is a total game changer. It says, what if dark energy isn't really a thing at all?
The theory says that as the universe gets older, this fundamental prime wave grows. And as it grows, the universe's most basic unit of length, something called the Planck length, actually starts to shrink. So imagine you're looking at a faraway galaxy. If the ruler you're using to measure its distance is secretly getting smaller over time, that galaxy is going to look like it's moving away from you faster and faster.
This means dark energy might not be some mysterious force pushing the universe apart. It might just be a cosmic illusion. We think we're seeing acceleration, but what's really happening is that our very standard of measurement is changing, all dictated by the rhythm of this prime wave. It's a really profound shift in thinking.
And here's the best part. This isn't just a cool story. The theory makes a real, concrete, testable prediction. This equation here is basically its fingerprint. It connects omega, which is a number astronomers use to measure dark energy, directly to p, which is the prime wave. It predicts that the strength of dark energy should look like it changes as we look further back in time. And our telescopes are now getting good enough to actually check if this fingerprint is real.
So if this wild idea can explain the entire cosmos, what about the atom? Well, get this. The theory says the exact same prime wave is at work, just on a completely different scale.
So the idea is that a tiny little echo, a ripple from this cosmic prime wave, exists even inside an atom, and this ripple creates a kind of energy landscape that decides whether a nucleus holds together or falls apart. The best way to picture it is to think of a boat on a wavy sea. So the atomic nucleus is the boat, and the prime wave ripple creates these waves, these peaks and troughs of energy.
Now, if a nucleus is just the right size, it can resonate and settle down into a low-energy trough. That makes it stable. But if its size forces it up onto a higher energy peak, it gets unstable and is much more likely to decay. Those famous magic numbers in nuclear physics? They might just be the points of perfect resonance with this prime number ripple.
Okay, so we've connected the cosmos and the atom. There's one big mystery left on our list: dark matter. And the theory's explanation for this one ties right back to that idea of our shrinking cosmic ruler.
The theory asks a really wild question. What if our universe isn't the first? It suggests that the shrinking of our reality is actually our entire dimension compressing. And in that scenario, dark matter isn't some new kind of particle. It's just the leftover, compressed regular matter from a parent dimension, whose gravity is still sort of bleeding through and affecting ours.
And this idea also spits out a very precise number. By comparing how much dark matter we see today to how much regular matter we see, the theory calculates this exact dimensional shrinkage factor. It's a specific prediction that connects the biggest components of our universe together with a single constant.
So let's just step back for a second and look at the whole picture here. What does it all mean if one single mathematical wave can explain so much about our reality?
I mean, it's just an incredible unification. You have one idea, born from pure math, from prime numbers, and it weaves this single thread through the expansion of the universe, the stability of atoms, and the mystery of dark matter. It connects these huge fields of science that have always seemed totally separate.
The implication really is profound. It suggests that the physical laws we see around us aren't just random. They might be emerging from a deeper mathematical reality, a reality that literally pulses to the beat of the primes.
And that leaves us with one last big thought. Does a theory like this mean that the universe is fundamentally math, or is math just the most powerful language we've ever created to describe the universe? This theory kind of blurs that line, leaving us to wonder if we're discovering the laws of physics or if we're just finally learning the notes to a cosmic prime number symphony.